So the radio frequency ablation. Two types of current: alternate current, direct current. Alternate current is a current which changes its direction. It's an alternate current. Okay. And how many times it changes the direction is a frequency. So from this to that, that to this. So this is an alternating current. And how many times it will go to there and come here is an frequency, right? And the another is power of electricity. So how this is correlated and important for a radio frequency ablation is, see now what you do is, so let's do one thing, okay, we'll do one experiment. So now watt is the power of electricity, which is an multiplication of volts multiplied by ampere. This technical thing should keep aside. Now take this thing. So, okay. So now there are two things. One is the frequency you are doing, correct? And another your pressure you are applying. You are putting some power there, correct? So now 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, and you will see that there is some energy. There's some energy there. Okay. So this is one thing. Now do one thing. Increase frequency. You will see that heat is generated, right? Or increase the power with same frequency. You will see that heat is little more generated. If you increase the frequency, there is a chance that the generated heat will be more. If you increase the power, there is a chance that generated heat will be more. Right? Clear till this time? Fantastic. So this one thing we'll keep it in mind and we'll go out. So what happens is there is something called as a radio frequency. When this frequency is beyond 3 lakhs hertz, it is called as radio frequency. The machine which converts your AC into radio frequency is called as a radio frequency generator. You must have seen the radio frequency generator, right? The machine is called as a radio frequency generator. So there is one machine there. Now what happens is you have another thing which is called as a radio frequency probe. So there will be one probe which is connected to the machine, and you had another thing that is called as radio frequency cannula, right? So cannula we will put into the desired location. Into that cannula we will put a probe, and that probe is attached to the machine. Correct? Is this clear till this time? Cannula has a exposed tip, right? And the another tip which is covered by insulated material. Okay, so non-insulating tip is the important part of the cannula. Okay, so there will be a non-insulated tip and the insulated tip. Now what happens is there is one more thing attached. We attach a pad which is applied to the distant part of the body, and that pad is also connected to the machine. Are you clear to this thing? Right? No? Fantastic. You have to switch off the. When the frequency is converted to the radio frequency, what will happen is at the distal end of the probe, there will be a ionic mechanism where due to the current, ionic particles will move to and fro. Correct? Right? So that frequency is transferred from generator to the cannula, tip of the cannula via probe. Right? And what will happen is there will be a movement of the ionic particles. Right? From tip, near the tip. And that frequency will be carried away through the pad which we have attached. But pad you attach is pad should be a bigger size, because the electricity disperse. If it is into bigger side, it will not cause a lesion, right? or it can cause the burn there, right? That's why the pad should be bigger size. Now, this movement of the ions near the tip, what will it happen? There will be a to and fro movement of ionic particles. At the same time, there will be few non-ionic particles which will not be moving, and there will be a collision between the particles which are moving and which are not moving. Is that correct? And that collision will generate a heat. Clear, Kanchan? Try and understand the concept. Don't you can choose not to write. Okay. So first understand the concept. That collision, because once you understood the concept, everything else is easy. So that collision will generate heat. So heat is, the probe is not heated. The job or the function of probe is not to hit. But what will it do is, now again, what will it do is, say suppose we are doing this, okay? Once the temperature is increased after a certain level, my brain will get a signal that, okay, this much temperature, now it is too hot. So I will either decrease the power or the frequency and try to decrease the temperature. The same way, probe will maintain the temperature by decreasing the power. Here, the frequency will not change because frequency is fixed. So only thing you have to change is the power. Or only thing that can be changed to adjust the temperature is power. Understood? कळलं का नाही कळलं? You can say no. वाटत नाही तुझ्याकडे बघून. You understood, no? So now there are two things which are creating the heat over here. One is the frequency, one is the power. Now in radio frequency machine, frequency is fixed. Now what changes is the power. If I increase the power, temperature will increase with the same frequency. If I decrease the power, temperature will decrease with same frequency. The same thing will happen. The probe, once you have adjusted the temperature, for example, you had adjusted the temperature at 60-degree temperature, okay? So that will, till the temperature is raised, frequency is same, the power will be more, and that power will cause more power will increase the temperature due to at the tip, okay? And once that temperature is reached, what will happen is it will cut down on power, right? Because the temperature is reached to maintain the temperature. After some time, what will happen? Temperature will again start coming down. Then again there is a possibility that power will be increased. This is how the temperature is maintained, approximately plus minus 1 degree centigrade in a newer machines or less than that. Am I clear? The job of probe is not to hit. Job of probe is to maintain the temperature. Now, what happens is, there are three types of radio frequencies. Okay, one is conventional, one is pulse, and another is cool radio frequency ablation. So, in short, we will understand the difference. Conventional is, this is frequency and it is continuously going with some power till the temperature is maintained. Okay, this is conventional. Pulse is you are giving a current into pulses. For example, see, this is conventional, right? Pulse is, so what is happen is, there is a certain gap, that is a pulse. There is certain gap between the two movements, and that is the reason temperature will not rise very high, right? If you go on doing this, temperature will rise very high, but if you go on doing this, temperature will not rise. You can do it and you can test it. So do it for 30 seconds. Temperature rising. Now do it in the same pulse and show me that temperature is very high. Do it in pulse. Do it for some time and take a break. Temperature will not rise. Because for some time the temperature is, you are not doing something which causes a rise in temperature. This is called as pulse radio frequency ablation. Right? Is this clear? Great. Now, so what happens is, what are the factors? So you have a radio frequency generator, you set the temperature, frequency is same. Till the temperature is raised, your power will be more. Once that temperature is achieved, your power will go down. Once temperature comes below certain level, again the power will increase, and that's how the temperature will be maintained. So here RF probe or thermocouple, what we call it as, the job is to maintain the temperature. Clear? Is everything clear up to this moment? Now what happens is, when you are using a conventional radio frequency, say suppose this is your exposed tip, okay? When we are doing an conventional radio frequency, usually the temperature, rise in temperature is around 4 to 5 mm parallel to the exposed tip. In conventional, the rise in temperature is parallel, not much beyond the tip. So say suppose this is a tip, okay, this will be an area of the temperature, not beyond the tip. Color?
Yes.
Sunita, color? So for the conventional radio frequency ablation, the temperature, area of the temperature heat will be created around parallel to the tip, not beyond the tip. What is the significance is, your nerve, say this is an area which is heated, this is an area which is, say suppose you are maintaining 60 or 70 degree temperature, and your nerve is here. I am talking about a conventional radio frequency ablation, and you had put the nerve like this. Your nerve is here and my tip is like this. There is a chance that my nerve, I will get this sensory stimulation, I will get the motor stimulation if there is some motor fibers into the nerves. But if I am doing a conventional radio frequency ablation, my nerve might not get completely ablated if the tip is perpendicular to the nerve. Clear on to this? Clear on to this?
Yes.
So how should I place the needle? The needle should be placed lateral to the nerve, and then there is a very high chance that nerve will get ablated in a conventional radio frequency ablation. And exactly this is very important into the facet. So what happens is, this is spine model. What happens is this one. So your median branch, median bundle, suppose comes from, this is a SAP, this is a transverse process. From medial branch will lie over here somewhere like this, right? So यहाँ से आके it will come and go like this. Now, if for a conventional radio frequency ablation, as we go into a diagnostic block, if we go into tunnel vision at the same time, and if I put my needle like this, the nerve is perpendicular to the tip of the needle, okay? Tip of the RF cannula, and that's the reason conventional RFA you might not get a good relief even if there is a good stimulation, if your tip is perpendicular. Instead, what we have to do is, instead what we have to do is, for conventional, rather than starting at the same level, you start little inferiorly, maybe 1 or 2 levels inferiorly, and you put it needle, and you put needle at desired location. You understood? So there are 2 ways to put the needle over here. I can go in plane tunnel vision at the same level, but needle will be perpendicular. Or another option is, I will go 1 level maybe below and then put my cannula. This will not be a tunnel vision. This has to be, this will not be tunnel vision. And in that I will try to put my cannula which is parallel to the medial line. bundle. So while doing a conventional radio frequency ablation of the MBB for the facet, diagnostic you can go in tunnel vision at the same level, you can put the drug there. That's not an issue. But for the ablation, you have to go from little inferiorly so that your needle tip will remain parallel. Clear up to this? Now, second thing regarding the cervical facet. So cervical facet, this is an articular pillar, right? Spinous process, lamina, articular pillar. Here will be somewhere here will be your medial bundle, right? Branch. Now, for a diagnostic, we can go exactly perpendicular, and that's absolutely fine. Even we can go from posteriorly, even that is fine. Okay for the diagnostic. But if we have to go for the ablation, see the MBB is somewhere like this here. Okay, so if I go from here, I will not ablate it properly. So for the therapeutic, that is for the radio frequency ablation, a needle has to be parallel to the medial bundle, and that's why for the ablation of the cervical facet, your needle has to go from posterior to anterior. But for the diagnostic, posterior to anterior is also okay, or if you can go from the lateral and just hit the middle of the articular pillar, even that is okay. This is true for conventional radio frequency ablation. Clear? Okay. So these are the two important things. Even into the knee. If you are going perpendicularly, it will not ablate. But if you are going parallelly, then only the ablation will come. And even if you are perpendicular, you can get the stimulation, sensory and motor, but you might not get the good results. This is true for conventional radio frequency ablation. Now, so what is important is, now let's go for the pulse radio frequency ablation, right? Pulse is in pulse radio frequency ablation. Okay, sorry. Pulse radio frequency, the temperature rise is somewhere around 42 to 45 degree temperature, and it does not cause ablation of the nose. So ideally we should not be talking, the word is not a radio frequency ablation, okay, pulse radio frequency. So in a pulse radio frequency, the ionic moment is more beyond the tip. The ionic moment is more beyond the tip. And that's why the pulse radio frequency, as the moment is more beyond the tip, your tip should be perpendicular to the nerve. So here you might choose not to go parallel, but you have to choose a perpendicular, right? What is difference is, here the mechanism of pain relief is, lots of mechanisms are discussed. One is some electromagnetic changes, some is an anti-inflammatory changes. So those are the changes, but not yet confirmed thing that this is the reason why there is a pain relief in a pulse radio frequency ablation. Am I clear into this? Now there is one more thing, is a cool radio frequency ablation. So regarding the cool radio frequency ablation, as we have seen that in a conventional radio frequency ablation, thermocouple is the one which maintains the temperature, right? Once the certain temperature is achieved, the power is decreased, right? Now the lesion size. What are the various factors which can change the lesion size? One, a duration. Within a certain specified duration, lesion size can be increased, but beyond that, lesion size doesn't change. You increase the power, lesion size will increase. You increase the length of the tip of the cannula, the lesion size will be increased. You increase the breadth, that means you change the gauge of the needle or RF cannula, the lesion size will increase, right? Correct? But here, say suppose you have maintained a 70 degree temperature, Okay, 3 lakh frequency, your power is increasing, and once you achieve the 70-degree temperature, what will happen is power will decrease. That means your lesion size is also within a limited period. It will not be big. Because if you go on increasing the power, the lesion size after certain degree, till certain degree, the lesion size will increase. But as our temperature is fixed, what will happen is power will decrease, so your lesion size is limited here, right? So this exactly the disadvantage has been changed into the cool radio frequency ablation, where you have a cannula. Inside the cannula, there will be 2-3 things. One thing is that is a bigger size cannula as compared to the conventional radio frequency. So one itself is an increase in the. Second thing is there is one port for the thermocouple. There is another port where through which a water inlet for the water inlet, and another port there is for water outlet. So what will happen is, now here you can give a more power. So if you give a more power, if you give in conventional radio frequency, if you increase the power, your temperature will go on increasing beyond the limit. Here you fix a temperature, so power cannot be increased, and that's why lesion size is decreased. Here you give a more power, but additional temperature, rise in temperature, or the rise in temperature is controlled by the water flow. Right? So extra temperature will be controlled by water, flowing water. That means if the temperature is rising, the flow of water will be more, or if it is less, the flow of water will be a little bit changed. That means you can give a more power, and we can give a more power means one of the factor which decide lesion size is a power. That means lesion here will be a big, because we are giving a more power, and the temperature is controlled by the water. Am I reaching?
Here it is from the tip, or here
I will come to that. So this is one thing. Here the lesion size is big, because temperature is controlled by the water. We can give the more, right? And second temperature, the lesion is is rounded all over the tip. It is neither parallel not beyond the tip. It is all over the exposed tip, right? Okay. So the region is circular, oval. It goes beyond the tip. That means this is called